Hi everyone, welcome to the programming platform. My name is Arjit Nath, and in this video, we will go through the factory design pattern. Let's get started. At first, we'll look into what is factory design pattern. Then we'll understand why we require factory design pattern and what is the use of factory design pattern. Then we'll go to a very simple form of factory design pattern called the factory method pattern and its implementation. Then we'll see what is the actual factory design pattern along with this implementation. Factory is a creational design pattern which provides an interface for creating objects in a superclass but allows a subclass to choose which class to instantiate. Factory design pattern follows two of the major design principles. First is a single responsibility principle, which states that a class should have only one responsibility. Furthermore, it also states that it should have only one reason to change. This helps make class loosely coupled and better organized. Second is the open-closed principle, which states that a class should be open for extension but closed for modification. In this process, we prevent ourselves from modifying existing code and cause new potential bugs. Now, what is the use of factory design pattern? As previously mentioned, the open-close principle states that the class should be open for extension but closed for modification. This means that when we define the code in a particular class, we have to make sure that the class is implemented via an abstract class or an interface, such that in future, if we want to provide a new or different implementation to that class, we don't have to update any existing class in any way. Now, the interface or abstract class forms the backbone of factory design pattern. Tying your code to a concrete class can make it fragile and less flexible. The main responsibility of the factory design pattern is to ensure that the object creation and instantiation part of the code is separated and decoupled from the main business logic. When the volume of different types of objects increases, the object creation section will be the major source of change in the code. Separating it from the business logic will make sure that the business logic maintains both the open close principle and the single responsibility principle. Consider the following code where we are trying to create a service for our pizza delivery store to deliver pizza to customers. Currently, we have four different kind of pizzas: cheese pizza, pepperoni pizza, sausage pizza, and veg pizza. The pizza abstract class provides the default implementation for all the pizza types, but the same can be overridden in the respective pizza classes. From the main method, we are creating an object of the pizza store and calling the method order and passing the type of pizza we require. Over here, we require the pepperoni pizza type. The pizza type is present in the constants package, which stores the name of all the pizzas that are present in our pizza store. Since this is an enum, this will serve as a dictionary for all the different types of pizzas present in the pizza store, and this will also as an easy access for the pizza names. Now, the order method in the pizza store takes in the pizza type that is being passed over from the main method. Over here, we are asking for a pepperoni pizza. If you see the order method, the first thing that it is doing is creating the type of pizza depending upon the pizza type that we are sending from the main method. It will create an instance of the pepperoni pizza type because we are sending pizza of type pepperoni. And then once we know the type of pizza that has been ordered, we will start the pizza preparation process. That is, it will call the prepare method, the bake, the cut, and the box method. So if we distinguish this order method into two sections, this first section will be the object creation section, that is, we'll understand what type of pizza to make. And then this is the business logic section where we are actually preparing the pizza. Let's execute this code to see how it works. We'll go to the main method and run this method. If you see over here, it is executing the business logic and it is saying preparing pepperoni pizza, baking pepperoni pizza, cutting, and boxing. Depending upon the methods, that is a business logic that we have called over here. Since we chose a pepperoni pizza, the prepare method will take the details from the pizza abstract class, that is preparing pizza name pizza. Now where this pizza name value is coming? The pizza name value is coming from the respective pizza classes. Like if we open the pepperoni pizza class, we will see that the constructor is setting the pizza name as pepperoni. And this is where the pizza name is being translated to this protected variable. And that is how we are seeing preparing pepperoni pizza, baking pepperoni pizza, cutting and boxing. Now, if we give over here cheese pizza and execute this main method, we will see it is preparing cheese pizza, baking, cutting and boxing cheese pizza. Now, where is this name cheese coming? The cheese coming is from the cheese pizza class, which is setting the pizza name as cheese. Now, even though it looks fine, consider in the future we want to add a few more pizzas to our menu or remove an existing pizza type which is not selling well. Then we have to modify this class and add a few more if statements for the new pizzas which we want to add and remove few of the existing if else statements for the pizzas we want to remove from the menu. This means that every time we want to add or remove pizza types, we have to modify this class. This is directly violating the open close principle as this class is being modified whenever we want to add or remove pizza. And also, if you look closely, this class is serving a dual responsibility. It is creating the pizza type as well as the business logic. Thus, it is also violating the single responsibility principle. So, how can we improve that? One thing we can do in this scenario is to remove this object creation section from the code and place it into a new factory class called the pizza factory. Let's see how that can be done. Over here, we have created a separate class called pizza factory and inside that a method called create pizza and we are taking the pizza type. And we have kept the if else condition statement inside this method and depending upon the pizza type, we will create an object of the pizza and return it accordingly. Thus, the sole responsibility of the factory class is to deliver objects based on the type request of the customer. Inside the pizza store, what we can do is we can create an instance of the pizza factory and initialize that in the constructor. And in the order method, first we can call the pizza factory.create pizza and send the type of pizza that we require. So this will go ahead and create an object of the type of pizza that we want and return that. Using the type of pizza, we can call the prepare, bake, cut, and box method of the pizza. So if it is a pepperoni pizza, it will call the prepare, bake, cut box of the pepperoni pizza. So for cheese and other types. So inside the main method, we are creating a pizza store object and in the constructor, we are sending a new pizza factory object. So if you see the constructor here, the pizza store parameterized constructor requires a pizza factory instance such that it can create the type of pizza and send it to the order method when required. So we are creating a new pizza factory here and then calling the pizza.order and we are saying we require a cheese pizza. Let's run this program. So if you see over here, it is saying preparing cheese pizza, baking cheese pizza, cutting cheese pizza, and boxing cheese pizza. Let's try a different type of pizza. Say we require a sausage pizza. Let's see how it works. If you see over here, it is preparing sausage pizza, baking sausage pizza, cutting sausage, and boxing. It is doing the same operation but for a different type of pizza. Looks like this is working just fine. So what we have seen over here is the most simplest version of a factory design pattern. Why don't we take another step to see how can we scale our new pizza store? Okay, say our first pizza store, which was in London, is a huge success, and so we thought of opening two more stores, one in Paris, the second one is in Lisbon. Now, as a part of the scaling process, we can create two more factory classes. We can rename this to London Pizza Factory, the other one can be Paris Pizza Factory, and the Lisbon Pizza Factory. So we can create as many factory classes as the number of stores we are opening. In that way, we only have to pass this factory class as a part of this pizza store constructor creation and we are done basically. But this approach gives us a little less flexibility and a little less control over how we are approaching the architecture. Think of all object-oriented problem as a real-life scenario. In our first store in London, we had a certain way of preparing our pizzas. Now, the way the pizza is prepared in the other locations may depend upon the place where we are opening the store. Our next store that is in Paris may have a slight different dough thickness or style of preparation, what we are seeing over here is that the pizza store has a relation in which the pizza is cooked. Previously, we considered the pizza store and the pizza creation method as two separate entities, but that may have to change for the better. Now, rather than creating separate pizza factory for the different stores, we can bring this create pizza method in the pizza store class. This will give us more control of the pizza creation for different location. Let's see how we can do that. For that, we have to convert the pizza store into an abstract class and create a protected abstract create pizza method which returns a pizza type inside the pizza store. So we have to remove the pizza factory, bring the create pizza method inside the pizza store as an abstract method, and create the pizza store as an abstract class. This will actually give us more control over the pizza creation depending upon the pizza store location. Since pizza store is now an abstract class, we have to provide implementation to the create pizza method. For that, we have created three different classes for the three locations where we are starting the pizza store. That is the London pizza store, the Paris pizza store, and the Lisbon pizza store. So if you see over here, each of the pizza stores extend the pizza store abstract class. This is the pizza store abstract class, and the London pizza store is extending the pizza store abstract class, and it is giving an implementation to how the pizza should be created. Similarly, the Paris pizza store is providing an implementation of how the pizza should be created for the Paris store, and the Lisbon pizza store, again extending the pizza store class, gives an implementation on how to create the pizza in Lisbon. Now, let's say the London pizza store has a special type of cheese pizza, whereas the Paris pizza store has a special type of pepperoni pizza, and the Lisbon pizza store has a special type of sausage pizza. So, while the pizza creation is being done, we are saying that if from London pizza store we are ordering a cheese pizza, we can directly instantiate the special London cheese pizza class rather than the normal cheese pizza class which we have seen in the previous example. In the special London cheese pizza, pizza being an abstract class, and it is expecting the pizza name in a protected string format. And we are overriding the prepare method and saying that it is a special cheese burst pizza. Similarly, for the Paris pizza store, when we are calling this create pizza method and say we are asking for a pepperoni pizza, it will actually go ahead and return a special Paris pepperoni pizza object, which has a thin crust. Similarly, for the Lisbon pizza store, when we are ordering a sausage pizza, it will return an object of the special Lisbon sausage pizza. Let's go to the main method to see how it works. In the main method, we are creating a London pizza store object inside a pizza store abstract class, and we are calling the London pizza store dot order, and we are asking for a cheese pizza. Similarly, from the Paris pizza store, we are ordering a pepperoni pizza, and from the Lisbon pizza store, we are ordering a sausage pizza. Let's run this code and see how it works. So if you see over here, for the London pizza store, it is giving a cheese burst special London pizza, whereas the rest of the process is same. For Paris, it is giving a thin crust special Paris pizza, whereas in Lisbon, it is giving an extra sausage special Lisbon sausage pizza. The main objective of this code is to let you understand the level of flexibility factory design pattern provides in object creation. Every class that you see over here maintains the single responsibility and the open close principle. Say, going forward, the London pizza store decides that they want to have a special pepperoni pizza. What they need to do is they need to add a new special London pepperoni pizza class, extend the pizza abstract class, and provide an implementation for the preparation section. After that, we have to initialize the special London pepperoni pizza class over here in the London pizza store in this section. This is how the factory design pattern works. The factory design pattern is a good example of how to enforce the single responsibility and the open close principle to your program architecture, and it helps in keeping your code extremely loose coupled and organized. In the next video, we will go through the abstract factory design pattern. Please like and subscribe my channel for more videos on design patterns, software architecture, and data structures. I will add the GitHub link of the code in the description section below for easy reference. Thank you.